Hello there again everyone, my name is Marinduque. For today, I will be recording my laboratory exercise 4 for IT 211 Data Communications and Networking 1 CISCO 1. In network system, it is very important to communicate even in longer distances. As we already knew, a connection inside a building is a LAN connection in which we can communicate any end device inside the premises. The problem is how we can communicate outside the premise. The solution is to connect various LANs. The intermediary device responsible for this is the router, in which it selects the best path by locating the IP address even in different networks. The knowledge in topology, IP addressing, and LAN design is very essential to understand this experiment. The objectives of this laboratory is to configure router connection, construct a LAN-to-LAN connection, and design a simple network topology depending on the application. The materials that we need is a CISCO packet tracer. Procedure number 1. Open the CISCO packet tracer, connect 3 PC and 1 hub. This will serve as your LAN A. In connecting PC to hub, you can automatically set the appropriate cable type by dragging the cursor network component box, and under connection tab, we can select Smart Connection. Once we are done opening the CISCO packet tracer, we have to go down here below in the end devices and choose 3 PC. To find the hub, we can just simply click Network Devices and choose PT-hub. For us to be able to connect these devices to one another, we have to choose Connections and select the Automatically Choose Connection Type. For step number 2, the PCs in LAN A should have different IP addresses. Example, one PC in LAN A has an IP address of 192.168.1.1, while in another PC it can be 192.168.1.2, and so on. Configure each PC's individual IP addressing and connect it to a hub. For step number 3, choose a router. We can select 1841 router and it will act as router A for LAN A. In the network component box, click on the router. Fourth step, construct the network in LAN A as shown in our module. For number 5 step, click on the configuration mode of router 0 to start the configuration. Step 6. After the device has finished booting, change the display name of the router to CISCO 1. Changing the display name does not affect the configuration. For number 7, click on the hostname field and type CISCO _1 and then click the tab key. Note the equivalent iOS command is entered in the lower portion of the window. For number 8 step, click on Interface Fast Internet 0/0 and designate the IP address. The subnet mask should be 255.255.255.0. For the 9th step, click the port status to on, making it enable. So let me explain a little thing that's going on before. As you have noticed in the first attempt of me trying to have this green light in between CISCO 1 and copy CISCO_1, it has actually given me the red triangle light. Now it's obvious that something is wrong with that, because as per the module, it should have like 2 green lights in between. Like there should be 2 green lights blinking in between. So I just, it took a while. I just kept on changing some sort of like here in the physical, as you can see a while ago, I was trying to change and choose another like modules in here, replacing here and there, and it's also the same thing that I've done here, because before a while ago, I'm not so familiar with this one, but as I noticed a while ago, it's both empty, so I just kept on experimenting, and then that's it. After that, I went to the configuration again, and I clicked the serial 000 and I entered an IP address. The moment I enter the IP address in here, the green light starts to appear on this copy, and same thing happened in here when I actually went to serial 000 and entered an IP address here, and then both of the green light has appeared. I have received an email from my work. I have to pause this video for a while. There you go. We have managed to successfully show the green light between the two routers in there, but we are not really sure why is the connection between the hub and the router shows red. So the indication that it is successfully connected is there should be two green lights blinking. One is located at the output of CISCO 1 and the other one is in the input of copy CISCO_1. Okay everyone, now we're done with the laboratory for the CISCO packet tracer. Now we can move on with the question to be answered also in this video. The first question, what is the importance of routing? Routing is the hub around which all of the IP connectivity revolves. At the simplest level, routing establishes basic inter-network communications. It actually implements an addressing structure that uniquely identifies each and every device. The router organizes individual devices into a hierarchical network structure. Traditionally, routers have also served as the media adapters that have connected remote offices to the headquarters via WAN. It only means the router has become the primary control point in the increasingly complex network environment. It is holding the most responsibility for service quality and security, monitoring and efficiency, and other attributes that allow networks to add value. If you control the routers, you control the network. Question number 2. Why do we need a router? Why not use switch or hub? Hubs, switches, and routers are all computer networking devices with varying capabilities. Unfortunately, the terms are also often misused. Hubs, switches, and routers are all devices that let you connect one or more computers to other computers, network devices, or even other networks. Each has two or more connectors called ports into which you plug in the cables to make the connection. Varying degrees of magic happen inside the device, and therein lies the difference. I often see the terms misused, so let's clarify what each one really means. When we say hub, it is typically the least expensive, least intelligent, and least complicated of the three. Its job is very much simple. Anything that comes in one port is sent out to the others, and that's it. If a message comes in for computer A, let's say, that message is sent out to all the other ports, regardless of which one computer A is on. And when computer A responds, its response also goes out to every other port on the hub. Every computer connected to the hub sees everything that every other computer on the hub sees. The computer themselves decides if they are a targeted recipient of the message and when a message should be paid attention to or not. The hub itself is blissfully ignorant of the data being transmitted. For years, simple hubs have been a quick and easy way to connect computers in small networks. Switches. A switch does essentially what a hub does, but more efficiently. By paying attention to the traffic that comes across it, it can learn where particular addresses are. Initially, a switch knows nothing and simply sends an incoming messages to all ports. Even accepting the first message, however, the switch has learned something. It knows on which connection the sender of the message is located. Thus, when machine A responds to the message, the switches only need to send that message out to that one connection. In addition to sending the response through the originator, the switch has now learned something else. It now knows in which connection machine A is located. That means subsequent messages destined for machine A need only be sent to that one port. Switches learn the location of the devices that they are connected to almost instantaneously. The net result is that most network traffic only goes where it needs to, rather than to every port. On busy networks, this can make the network significantly faster. Routers. A router is the smartest and most complicated of the bunch. Routers come in all shapes and sizes, from the small 4-port broadband routers that are very popular right now to the large industrial-strength devices that drive the internet itself. A very simple way to think of a router is a computer that can be programmed to understand, possibly manipulate, and route the data that's being asked to handle. Many routers today are in fact little computers dedicated to the task of routing network traffic. As far as simple traffic routing is concerned, a router operates exactly as a switch. Learning the location of the computers and its connections, and routing traffic only to those computers. Consumer-grade routers perform at minimum two additional and important tasks: DHCP and NAT. DHCP, or Dynamic Host Configuration Protocol, is the way dynamic IP addresses are assigned. A device asks for an IP address to be assigned to it from upstream, and a DHCP server responds with an IP address assignment. A router connected to your ISP-provided internet connection will typically ask your ISP server for an IP address. This will be your IP address on the internet. Your local computers, on the other hand, will ask the router for an IP address, and these addresses are local to your network. Question number 3. Why it is important that each PC has different IP address? What will happen if we will use the same IP address? If you have been around computers and on the internet for any length of time, you may have heard the term IP address. Although, you may have heard about them. You may not know exactly what they are or what they are important. Why do unique IP address matter? Why are they important? IP stands for Internet Protocol. An Internet Protocol address, or IP address, is a unique identifier given to every machine in a network. An IP address serves two primary functions. It is used as an interface identification for a network of machines, and it also serves to provide a location of that machine, much like a physical address for a home or business. Because an IP address is a unique identifier, it allows computers to send and receive information to and from specific computers in a given network. Today, there are two standards when it comes to IP address: Internet Protocol version and Internet Protocol version 6. When you put a website on the internet, you have a number of options when it comes to hosting. Most people don't go through the expense or the hassle of setting up their own server and effectively becoming their own web host. So their options would be to use a dedicated server or shared hosting. Because of an IP address, it allows computers to send and receive information to and from specific computers in a given network. What will happen if we will use the same IP address? Data from a server is sent in small bits called packets. In an IP conflict, some packets will end up in one computer while some other packets will end up in another computer. So, overall, none of the computers get the data as the original message or picture being sent by the server cannot be retrieved in only half the packets. So, it will show up as an error. But note that two computers on the same local networks have the same public IP. A typical home network scenario with about 5 internet devices, the router is responsible with a public IP. This router assigns a private IP to each computer. These routers have network address translation inside that masks the private IP of the computer with the public IP of the router. A server across the world to which you request a web page from will actually see your public IP and not your private IP. So in this case, all your 5 devices in your home connected to the same router have the same public IP address. In general, the DHCP or Dynamic Host Configuration Protocol is responsible for assigning dynamic IP addresses to each device connected to the network. It is usually found in router. In a large network of computers, they might have their own DHCP servers, and it is unlikely that a DHCP server will make the mistake of assigning two identical IP addresses. Question number 4. What can I conclude from this activity? I therefore conclude that IP address is something that we probably rarely think about, but it's vitally important to our online lifestyle. Without an IP address, we wouldn't be able to get today's weather, check the latest news, or look at videos online. Because without the IP address, websites like whatismyipaddress.com or CNN or ESPN wouldn't know where to send information you ask for. They wouldn't be able to get to know your computer. Thank you once again for being with me in this activity. I am really thankful and humbled for you have taken time and effort getting through and checking my laboratory form. Please be with me on my next laboratory, and thank you once again.